Welcome and thank you for attending Team Rio's final presentation of our Biomed IT domain project. During this presentation, we will be covering basic background information about the project, what we produced as a team for the project, if the project was a success, an assessment of project management tools, estimated versus actual hours, what went wrong and what went right, lessons learned, project manager information, team dynamics, and sponsors' final assessment.
Team Rio worked with the Biomedical Engineering Department of the Southern Nevada VA Health System to develop a biomedical domain and new asset tracking database. Team Rio selected this project because we felt that the need was greatest, and it allowed Team Rio the honor of providing a proof of concept that would improve the quality of care provided to military veterans throughout Southern Nevada. The end state was to provide a single source for IT-related problem resolution and to improve on the existing access management system that is 20 plus years old. Working with the project sponsor, Brendan Kikuyu, it was determined that the biomed domain was their number one priority for the project due to the issues routinely experienced when assisting end users. The current VA domain consolidates clinical and administrative user accounts and computer accounts into a single domain. This domain is owned and managed by VA IT staff. However, VA IT staff are not allowed to work on devices that affect patient care. This is the sole responsibility of the biomedical staff. The basic rule is if it touches a patient or patient data, then VA IT is not authorized to work on it. This seems like a simple concept. However, the VA's decision to consolidate clinical and administrative functions into a single domain without clearly defining responsibilities causes a lot of confusion when a user reports a computer issue. A typical trouble call scenario that plays out dozens of times a day is this. A nurse or doctor calls the IT help desk to report a problem with their computer. The IT staff generates a ticket and places it in their queue. Once the IT staff makes an assumption that the computer touches patient data, they will tell the user to call Biomed. The user then calls Biomed and again explains the problem, only to be told by a Biomed staff that it's an IT-related issue and to call IT. The frustrated user now gets stuck in a pointing finger loop between IT and Biomed. Eventually, a meeting between IT and Biomed takes place where they finally decide which department is responsible to fix the issue. Typically, this ends up being the Biomed staff, even though they don't have any elevated privileges to fix domain assets. Finally, after a far too long process, the originally reported problem is resolved. To provide context, to add a computer to the VA domain takes approximately 21 days. The domain that Team Rio developed will eliminate the finger pointing and give nurses and doctors a single spot to report all computer-related problems.
The team produced a prototype example of the Biomed IT department project that was mainly comprised of three parts: the domain, the security, and the database. We'll be getting into this a little bit further in detail into each of these sections in the following slides.
previously, when we built the domain for the biomed staff, the first thing we had to do is assess their capabilities. And as stated, none of their technicians are currently Microsoft certified. Therefore, we had to build the domain in a way and at a level that would not overwhelm them. So here you can see on the left hand side, I have the domain, in this case, the first domain controller that I built. I also have another domain controller, if I were to bring it up, just to show that I have multiple domain controllers. Obviously, you want to build more than one for redundancy in case one goes down. And obviously, there's some technologies that you can use to cluster them, so on and so forth. But looking at my roles on the server, you can see that I have basically just Active Directory and DNS installed. If I were to click up here and add roles and features, run through the Microsoft Wizard, you will see that there are many other roles in this case. And if I go to the next tab, I would be able to see all the different features. Again, we wanted to keep this very basic in order to provide the proof of concept that the sponsor was looking for, while at the same time not overwhelming them. Some of the things that we recommended, obviously, would be a DHCP server, very easy service to set up, which will provide some dynamic IP addressing. You could also do things like document and print services, so they can do some of the file sharing if they want to use Microsoft for that. IIS for any type of web services that they might want to run. And also Windows deployment service. This is really a good service to push out updated software to end clients. Right now, the VA uses some other type of application. And what it does is it basically pulls bits and pieces from hundreds of machines throughout the network to install the operating system on some of their end clients. I've watched this on numerous occasions, and I've seen it take up to 4 hours to install Windows on a machine. Reason being because it pulls from different machines. You never know if you're going to get one that's a robust machine or maybe it's overtaxed or whatever. However, on the Biomed domain, if they were to install just something as simple as Windows Deployment Service, they would be able to do that straight from the server and cut that down from 4 hours to 20 minutes. I've seen it work. Looking a little bit further into the actual domain as it's set up right now, we did build a couple of different units, organizational units that replicate the actual settings of the hospital. 1 West, 6 East, and 6 West are all surgical inpatients. So these are all patients that have completed surgery and now they're going to come out to these different wards. In fact, 1 West is kind of the overflow for 6 East and 6 West. But what you'll see is that underneath each organizational unit, we put an OU for computers and an OU for users. This is so that way we can segregate out and apply different policies to computers, and it also gives us the added benefit if we wanted to, we could go in and actually delegate control to some of these different OUs, so that way super users within that ward would be able to manage it. A great way to push some of the permissions down to more advanced users, which will then obviously help the end users get the support they need faster, while at the same time reducing the amount of trouble calls being submitted to the IT staff. Going a little bit further, you can see that we have our domain controllers. In this case, like I said, I do have 2 domain controllers. Right now I'm connected to 1. I have 2 also open. It's just minimized right now. I also built a Biomed domain, created a couple different users. Brendan Kukuyu was our sponsor, and then these 3 gentlemen are the IT staff. What they do is they manage the IT characteristics for the biomed staff. There's also biomed equipment guys who work on things like EKGs and radiology stuff. They weren't included in this proof of concept. What we then did is we put all these different users into this biomed IT security group. So if I go in here and go into the members, you can see all those users are in this security group. We then put this security group inside domain admins, which now gave each one of these users domain admins, so that way they can manage the domain as they deem fit once the project is over. But this is the basic setup of the domain. As you can see, the domain name is biomed.va.gov. Some of the basic characteristics of the domain, as far as how we set up the organizational unit structure within Active Directory, and then some of the benefits of how we can delegate control, how we gave biomed admin rights so that way they can manipulate the network. We also talked about some of the different roles and features that were installed and why we don't have additional roles and features. Again, trying to keep it not as complex for the biomed staff, but obviously giving them a lot of flexibility by incorporating Windows Server 2016. The basic setup of the domain, let's go ahead and look at two different clients connecting to the biomed domain. So the first one I have over here is just a basic Windows 10 client. So I've logged in as OneWest user, but just to show how it works, we just put in the username, onewest.user, and the password. And the OneWest user is able to log into the domain. So that user is over here in the OneWest OU underneath users. So there's the user. But one of the things that we talked about earlier in the presentation, or as an issue, was that it takes a long time for computers to be added to the domain. So what I'm going to do right now is I'm going to bring up client 2. This is client 2, haven't done any configuration to it, so I'm just going to log in. This is just the basic biomed account that I built into the Windows 10 operating system. So I'm logged into the Windows 10 machine now. Has not been added to the domain, so if I go over here to computers, you'll see that there is no client 2. If I go into any of these other OUs, you'll see that it's not. So what I'm going to do is I'm going to open up a command prompt, and I'm just going to test connectivity to the domain. So I'm going to type ping biomed.va.gov. So as you can see, I am getting DNS resolution from the biomed.va.gov DNS namespace. And actually, my first domain controller, DC01, is the one responding. It's .10. .11 is my second domain controller. So with that being said, let's see if we can go ahead and add this to the domain. Again, when we talked about this earlier, this was a 21-day process to add computers to the domain in the current VA settings. So I'm going to go over here, change some of the settings. So here we go. Again, this is Biomed PC02. Change settings. Change. This time I'm going to add it to the domain. Biomed.va.gov. It's going to prompt me for some permissions. So I'm going to type in administrator, and I'm going to type in the administrator password for the domain. Click OK. So now what it's doing is it's reaching out to the domain controller and basically asking permission to join the domain. While this is connecting to the domain, another thing I want to do is I want to come over here, and just to show that we can add users and we can do things, I'm just going to go ahead and I'm going to create a new user. And we're going to name this one for our awesome professor that guided us through this process of our capstone. It's following kind of the VA naming standard. And what I'm going to do, for the IT Pro, we had a default password that we used, so I'm going to try to use that default password here. I'm going to take this so a user does not have change his password to the next login. I'm going to hit next and finish. And as you can see, I get a warning saying that my password did not meet complexity requirements. That's one of the other things that we did set up on this domain, a minimum of 14 characters. So I'm going to go back and I'm just going to add a few characters. Click next. So now the professor has been added. In this case, I'm just going to put him in 6 East. So now he's a user within 6 East. Going back to my client 2, as you can see, it's now been joined to the domain. And like I said earlier, this is a 21-day process currently right now on the VA. You saw I did it in less than 2 minutes. So let's go ahead and get out of this server or workstation. Let's go back to workstation client number 1. In this case, I'm going to go ahead and log off. We'll sign out anyway, no big deal. So now I'm back to the client 1 login screen. I don't want One West user. I'm going to log in as our professor. And as you will see, the new user that I just created is now able to log into the domain. And on the other computer, client number 2, this is the one that I just added to the domain. And here in a few seconds, it'll pop up into my computer's OU, showing, there it is, that it's been added to the domain.
For the purpose of the pilot and due to time constraints, we just decided to focus on server security. We felt this will maximize the security implications and security benefits for the sponsor. Given that once we defined a secure base build server image, that image could then be used by the sponsor to replicate across their environment. In the next following slides, we'll demo some of those key security components on the server that we implemented, that being the CIS benchmark, encryption, followed by patching. In hardening the Windows server is to apply the CIS benchmarks. This was done by using a preset image from the Amazon marketplace for this pilot project. We used a CIS hardened image and launched it. But to validate that the server is actually hardened to the CIS standards, we're able to use a tool called SecEdit. With this, you can build a list of configuration checks that can be analyzed against the server configuration to validate that the CIS hardening steps have truly been set. In doing so, we just fire up SecEdit. There's a database already with pre-assigned configuration checks, and we simply analyze the computer. This is where it will post the log output. Hit OK, and the configurations have been analyzed. So we can jump into this first one in a password policy. We can see that the database settings that it's checking for are set here, and here's the computer settings. And as you can see, it puts this nice green checkbox there to see that we've passed those settings, and we can walk through the various subchecks and see that once again the checks have been validated against the benchmark, and that confirms that the CAS benchmark settings have been applied to the we'll show how encryption and validate that encryption is enabled using BitLocker on the server. If BitLocker is installed, you'll be able to find it, find the application, and it's the Manage BitLocker application. Once we go there, you can see the drives that are available for BitLocker. Here we see that BitLocker is off on the primary drive. However, on the secondary drive, BitLocker is on, and its indicator is here that it's obviously on and the lock is on next to it. One of the reasons that we didn't encrypt the primary drive is because this is a virtual instance in the cloud. Upon boot, you would need to put a password in, and unfortunately that's not available to me as an administrator when it boots. So just for the purpose of this pilot, we used BitLocker to encrypt on the secondary drive instead of the primary. Validate that the Windows Auto Update is configured to install automatically. So from the PowerShell, we'll run sconfig. And here, number 5, we can see Windows Update setting is set to automatic. And so once this is configured, it will check daily for patches and then dynamically install them.
For the database portion of what we produced as part of the project, we prototyped the database in Microsoft Access 365, and we hosted that on a Windows Server 2016 server. The database was split into a front and back end portion, where the front end is basically the user interface program where the user interacts with the database. On the back end is where the data is actually stored. This allows for multi-user support, so multiple users can use the database at once. The back end would be stored on the server, and the front end of the database would be hosted on each individual workstation of the domain. And then we're going to go ahead and look at a demo next. The asset tracking database demo is part of the Biomed IT project. So here we are logged into a virtual Windows machine hosted on the Amazon Oz service. Go ahead and double click on the shortcut for the database on the desktop there, and as you see, it loads to a login screen. Depending on your permissions, you'll get access to different options. We're going to go ahead and first log in as the professor here. Just some test accounts we set up. As you can see here, we get a list of all the assets that are currently checked out. If you want to see checked in and out, you can go ahead and search. So check that. There's none that we have checked in. You can click and look at the current users of the database. You can add new assets. As you can see here, you fill out all these details on each asset. It's checked out to, what location, as you can see here. These dynamically update. Your information is added. You can print that detailed screen. You can email this list in a variety of formats. But as you see here, there's no way to edit user logins, just the user contacts as far as who's checking stuff in and out, but not who can log in and out of the database. And there's also no way to run reports and see information about the data in the database. So if we go ahead and log back out, we log in as an administrator. You can see now there's more options. Edit user login. That'll open a list of user logins to add, and there's also an option to select reports. All assets, asset details, assets by categories, and we can go ahead and look at one of these. Contact book by last name. Or we can go ahead and look at assets by category. They're all vitals. Assets by location. They're all at the main location. If we went here and we changed this, and then ran this by location, you can see now it's divvied up by each location. So as you can see, there's a variety of reports. They can generate useful information and keep track of what's going on as far as the assets go. You can see down here at the bottom, it gives you a status on who's logged in, and then when you log out, it tells you. So, yep, this is the fruition of our efforts at the end of Sprint 4 for the Biomed IT Asset Tracking Database prototype built in Microsoft Access. Thank you, and thank you for watching our demo. As outlined in the project charter that we originally came up for the Biomed IT domain project in the A class, or class 1 of this Capstone project, the main project success criteria was defined as the team delivering value to the sponsor week after week based on a prioritized backlog or series of features that the sponsor wanted to see as part of the project. At the end of Class A / during the beginning of Class B, Team Row came up with that prioritized backlog, and we implemented it during the implementation phase of the project during the B class by both all the team members and the sponsor. This project was a success based on that success criteria, and the sponsor plans on implementing the project moving forward. Many project management tools were used throughout this project. The few listed here were the most useful to our team. The business case was a good initial document that outlined what the project was going to be all about. And the project charter gave a little more detail. The milestone report provided a nice breakdown of when the major goals we should be hitting at certain times during the project. The Gantt chart was a further breakdown that really laid out the timeline of every single piece of the project, and that was super useful to see. The product backlog, I think, in our project was probably the most useful project management tool or important piece, since it drove the implementation phase and the Scrum process, what we were working towards. The scope management was definitely needed, since it outlined what we were going to be doing or how far we were going to take the project. And then the work breakdown structure was good to see a breakdown of each step of the work during the execution phase.
For the estimated versus actual hours, our team chose to go with the Agile framework and use story points to track our actual capacity. In the beginning, we allocated 50 story points per week per Scrum member with a 4-week project timeline. 4 members, that total came to 200 story points per week, or 800 total projected story points for the project. In actuality, we were able to find some time savers by specifically in security, finding pre-configured deployments around the CIS benchmark rather than have to manually deploy those configurations. We were able to launch one right from the AWS marketplace, which saved us considerable time. And because of that gain in additional capacity, we were able to swarm around other items that we had under estimated time and work for. So really the difference is because we use the Agile framework, it allowed for the team flexibility to adapt on the ground as we were able to find places where we would gain some capacity and find areas where we needed additional capacity, and we're able to shift that around in order to take full advantage of the Agile framework and maximize our time.
During the project, there were many things that went right. The team was able to work together and communicate efficiently through WebEx meetings and Slack chat. The project owner did a great job in communicating with the sponsor to identify the needs of the project. The project manager successfully led each meeting by outlining what type of work was needed to be done each week. The Scrum Master had experience in Agile and was able to create a product backlog to keep the team on track, and also create a chart to keep track of the progress. Each Scrum team member was able to complete the task in the product backlog on time. Throughout the project, there was not much that went wrong. The team was able to communicate effectively and complete the task on time each week. The project manager was able to keep the team on track by updating the team each week, what needed to be done, and how the project was going. The project owner was able to successfully create the WebEx meetings each week and make sure the recording was available if anyone needed to review it. The product backlog was clearly defined, and every team member was able to stay on track with the task each week.
Uh, for the lessons learned for the project, we found that we need to establish effective and efficient communications on and collaboration tools early on. We jumped between two different chat programs where I think that lost us a little bit of time and capability. Ideally, going forward, we have those lessons learned and can implement a solid technology list that we will leverage for our collaboration tools. We also need to ensure that team members are fully committed. We had an extra team member. The communication wasn't very good, and so we spent a lot of time thinking that action items were being worked on, but in fact weren't, and then the team had to rush in at the last minute and make up those differences. We also need to provide more time up front for research. In kicking off the pilot, I think some assumptions were made, but further research proved that those assumptions were not necessarily incorrect, but maybe lacking additional depth of detail, which then didn't allow us to plan accordingly. And we had to use the Agile method to basically pivot and adapt to accommodate that lack of research. And then lastly is just to ensure we account for class overhead during week one of each course. The first week of each course, it's a little slow to kick off, and we're trying to understand what are our class commitments and understanding, and so that eats into some of the time for our project. So just accommodating that and accounting for that in our project timeline would be helpful.
The project manager of our team was selected by volunteer. He has received positive feedback throughout the timeline of the project and leading the team. Going forward, he is interested in incorporating project management into his career and pursuing certifications such as the CompTIA Project Plus, P2P Foundation, PMP, and P2P Practitioner to help incorporate that in his career going forward.
During Team Rio's final meeting with the project sponsor, there was admiration expressed on both sides. Team Rio was happy to have a responsive and supportive sponsor, and the sponsor was pleased with the final products and that we met his vision. The sponsor stated that configuring the domain in a sandbox environment and using the database on AWS allowed my staff to see what capabilities work for us and which ones do not. We are now more confident in the systems and ready to take this proof of concept into production.